Plastics, the bane to our existence. Hi, welcome everyone. Welcome to the fifth part in our little mini series that we're doing about the diminishing resources and deteriorating environmental conditions on our planet. We should be so happy, yay! No, I'm kidding. Today we are going to be talking about plastics. This is a much smaller video to the bigger video focusing on the paper called Global Warming, Climate Change, and Environmental Pollution, Recipe for a Multifactorial Stress Combination Disaster. It is by the authors Sarah Zandalinas, Felix Frasici, and Ron Mittler. This paper, I'm so sorry by the way if I mispronounced those names, this paper is going to be the backbone to this entire series, but today, plastics, plastics, plastics. That is our conversation. Okay, continuing this conversation about human activity on the environment, I would be remiss and the conversation would not be complete if we did not talk about plastics. So, what exactly is a plastic? Well, in short, plastics are an aggregate or clump of polymers. Okay, cool, a bunch of different polymers put together, but what is a polymer? A polymer is a large molecule made of thousands of repeating smaller subunits in a specific arrangement known as monomers. Plastics are created by chemically binding those monomers together to form a long chain or a polymer, and this whole process is known as polymerization. Okay, so that's what a plastic is. You might ask, what exactly do plastics have to do with the environment and why are they so detrimental? Well, first, many of these monomers are derived from fossil fuels, meaning that almost every plastic ever created needs oil to create it. So I want you to think of this. Think of all the plastic that surrounds you in this current moment. It could be plastic within your phone, within the device that you are watching this on. It could be a plastic mug that you have, maybe it's plastic in your headphones, maybe plastic in your wires or chargers, maybe the plastic in your seat. Plastic is virtually everywhere, okay? Now, I want you to imagine that plastic just in the surrounding area that you reside in right now. Now, imagine all of that as oil, okay? That's what plastics are. But it's not only just oil. No, 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 no. Plastic companies have to add other chemicals known as additives to stabilize, increase its resistance, for its color, help shape it exactly. However they want their plastic to come out with, they have to add additives in order for that to happen. And luckily for us, just kidding, that was a joke, the vast majority of these additives are toxic. And studies have shown that there can be upwards of 20,000 different additives in a single plastic object, with the average number of additives being a lot higher than you may think. One specific group of additives are known as forever chemicals or PFAs. These synthetic compounds have great resilience to degradation because they have what is known as a carbon-fluorine bond. Now, I want to show you this picture here of PFAs, and don't get scared. You don't have to know a lick of chemistry to understand this, okay? These segments here, where you see a C and a line and an F, this represents carbon bonded to fluorine. And this is the bond that we are talking about. It's the carbon-fluorine bond. This is what makes plastics last for hundreds of years not being degraded, making up the backbone of the polymer. But just like every other solid material, degradation does occur, and degradation is simply a fancy name for the process of something, or the plastic, being degraded or chopped into tiny pieces. Some of these ways include the following. So we have photodegradation, caused by the absorption of UV light or sunlight. We have thermal degradation, which occurs when a material is exposed to heat. We have hydraulic degradation, which is caused by the repeated exposure to waves or water over time. And we have what is known as mechanical and physical degradation, which occurs when a material is exposed to like a physical stress, such as pressure. And over on the right here is the entire process of plastics and the life cycle of plastics, starting with, extraction for the raw materials, oil. The oil then is distilled, so it becomes more of specifically what the companies need. Then it goes underneath polymerization to make really, really, really long chains. These long chains are added together with additives and molded into the desired shape, creating the plastic product. Now, this product can go of one of three paths. Can go and 12% of it is incinerated. It can go and be recycled, where this can be like a loop here, where it's recycled, washed up, downcycled, and recycled again. This can repeat a number of times. Eventually, though, however, it does get thrown away. And the third path here, they both lead to the landfill and oceans. This is not me saying you shouldn't recycle. That is not what I'm saying. I'm just showing the pathway. This also is a better demonstration of what is known as the carbon footprint for plastics of a single plastic. All of this is included, and this here, landfills and ocean, needs to be expanded, which we'll expand in the next two slides because it has a much bigger scope than most you may think. Because the majority of plastics takes hundreds of years to break down, it's important to consider where it's going and how it's going to affect the planet that entire time. Unfortunately, a lot of plastics end up in the ocean and landfills, keeping it out of sight for many of us, but having very real consequences on the aquatic ecosystems and ultimately us. Because of ocean currents, plastics and rubbish end up in specific zones in the ocean known as garbage patches, which most of these garbage patches are primarily made up of plastics, where debris eventually sinks to the ocean, causing havoc all the way down and on the seafloor. And in this figure, we can see all the specific sites within all the oceans of the Earth where these garbage patches exist. And we can see we have some in the North Atlantic, some in the South Atlantic, in the Indian and Southern Ocean. We have some in the South Pacific, and we have the densest accumulation here in the North Pacific. And you might have heard of the Great Pacific Garbage Patch. That's what this garbage patch here is. This figure here shows some specifics of the Great Pacific Garbage Patch, and this is to scale. So we can see this is the west side of North America. We have Mexico, San Fran, Vancouver up in here. Here's Hawaii, and we can see like this is the size of the garbage patch. It is 1.6 million square kilometers, accounting for about 3 times the size of France and about 2 times the size of Texas. This is just the surface rubbish, not including millions of plastic debris that has already landed on the seafloor or wreaked havoc for thousands of species. Now, remember about degradation? Well, when plastics are between 5 millimeters and 1 micrometer, it's known as a microplastic. When plastics are between 1 micrometer and 1 nanometer, it's known as a nanoplastic. Put that into perspective. Between 1 centimeter and 0.1 of a meter is a golf ball. A virus is less than 1 micrometer, and DNA is to the scale of nanometers. And it's important to note that nanoplastics are on the cellular and molecular levels. Lastly, I wanted to show you this figure 1E from the paper. Across time, microplastics in the ocean are going up. It's actually exponentially increasing from the exponential we've been seeing all along in this presentation. We can see that pesticide use is steadily increasing, and we can see that fossil fuel consumption is also steadily increasing from 1990 to 2017. While degradation explains how, leaching explains specifically the process by which a substance or chemical is extracted from a solid material into a liquid. I hate to bust your bubble, but all plastic water bottles or containers are leaching plastics and additives directly into your drinking water, especially if those plastics are heated or have any sort of fat with it. And microwaving any food in plastic is exponentially leaching chemicals into your food. Remember there are upwards of 20,000 additives in each plastic? Yep. Now, I want you to think about the delicious, almost too perfect rotisserie chicken. Those rotisserie chickens, they're 1, sealed and wrapped in plastic. Then 2, the chicken itself has some sort of moisture and liquid along with fats. And 3, is stored underneath the heat lamp. All of these are perfect conditions for plastics to be leached into our foods. These chickens are basically sitting in a bath of plastics. Just throwing that one out there. And that's why it's so important that we are aware and we educate the public about plastics and chemicals and additives. This next figure is going to explain bioaccumulation and biomagnification of a specific contaminant that get in and stay within our bodies. And again, this can be also used for pesticides and herbicides and fertilizers and heavy metals that we've already talked about. There's also thousands upon millions of other contaminants in our environment. It's kind of ridiculous. So bioaccumulation is the process where one species over the course of time accumulate and accumulate and accumulate that one specific contaminant just because they are exposed to a contaminant across time. Whereas biomagnification explains the process at each increasing tropic level, the organism is going to gain a significant increase in the toxic chemical. That means if we start here at the plant, due to previous exposure, the plant is going to have a very small level of contaminants. Then these grasshoppers are going to eat the plant, but they need a lot of plants to survive. So these grasshoppers are going to have more levels of contaminant because they eat a lot of plants that have low levels. Then at the next level, these smaller birds, they need a lot of these grasshoppers to survive. But again, these have a bigger amount than this level. So then these birds are going to have a significant level higher than the grasshoppers. And this works its way up through the system. And if you don't really understand this, that's okay. The next slide will really get into what tropic levels are, but that's just the general idea of biomagnification. So if we think about the garbage patches, a plastic bottle or any plastic material is exposed to the sun, to the water, to some heat, and other plastics touching it, all of which are causing tiny fragments or degradation to occur in the form of nanoplastics, and then leaching, of course, to the surrounding ocean. Just as a heads up. All of these additives are directly being leached into the ocean. Because they are so tiny, remember, they are on the molecular level, the micro nanoplastics are able to uptake into the cell, and this is the real problem here. Every living cell uptake these nano and microplastics. This is why plastics are such a problem to every living cell on Earth. Because when they go into the cell, they cause an increase in ROSs, or reactive oxygen species, and an increase in oxidative stress, which ROSs are an oxygen-containing reactive compound. And they naturally have both a positive and negative roles within the body. However, at excessive levels, or if there's a persistent increase in ROSs that can't be remediated, at excessive levels, it does more harm than good. Which, by the way, ROSs and oxidative stress levels are only going up and up because plastics take hundreds of years to degrade and our society becomes more and more stressful every day. At this increased level, it causes organelle damage and organelle dysfunction. It causes lipid and protein oxidation, and it also causes DNA damage, all of which are vital for the cell to function, to run. And this is why plastics, carbon footprint, is so complex and so hard to nail, because we don't know where these are going. We don't know what animals these are in. We just have to assume it's in every living system. And the only real long-term solution is to stop the use and production of plastics and invest in science to find ways to break down plastics that we already have. You guys still big on buying things in plastic? Your water bottles? Your to-go coffee? Yeah, makes you really think, huh? Okay, well, anyways, this is the end of this section. I hope you guys enjoyed. Let me know what I missed or what you guys think. I hope everyone has a great day. Know that I love every single one of you and that this is a safe space for everyone. And now, here are my sources.